Let's look at strategies 5 and 6. They really go together well with this problem. Number 5 is try a simpler problem. Take the problem you have, but try to make it easier, solve that, and then build from there and see how it might, that easier understanding, the easier problem might lend understanding to the more difficult problem. And number 6, if you're going to do a lot of iterations of something, if you're going to build a problem, you really need to work in a way where you have a system. You can keep track of your work. So a way to think about this problem is, okay, rather than worrying about an 8 by 8, because it's like, whew, that's overwhelming. You remember in the previous video, there were 64 squares that were small, plus the 2 by 2 squares, the 3 by 3 squares, the 4 by 4, and so on. And it's really hard to keep track of all those. So let's take a look at trying a simpler problem. What if the chessboard were just one square? Well, that'd be simple. Let's take a look at it. Here it is. I have some different chessboards that I've drawn here, and we're going to zoom in on them. What if what if a chessboard was just one square? How many possible squares are there? Well, there's just one. It's just the very outside of the square itself, and that's simple to do. What if the chessboard, though, were a little bit larger? What if it were 2 by 2? Oh, well, that's a little more work. Notice that I have 4 of these small squares. 1, 2, 3, 4. Now, if I want to briefly talk about working systematically, which is, notice I'm going in order like smallest chessboard, next biggest chessboard, but I also might want to keep track of the way that I'm counting all the squares, because that's 4 squares right there. And then there's also an overall square, like the square itself all the way around is a larger square, and that makes a grand total of 5. When I'm working systematically, though, I might want to keep track of how many small squares plus the next big square and so on. So I might say that there's actually 4 of the smallest squares, right? Plus 1 of the larger squares for a grand total of 5. Now, if you want to get even more systematic, you can really label these something like, what are the 4? What is the 1? But I'm going to leave some of the organization for you, because I'm not going to do this whole problem. I'm going to have you work on it. Now, what if that chessboard were a 3 by 3? How would that look now? Well, this is still pretty manageable because the problem's a lot easier than the real problem. How many of the smallest squares? Well, you can still count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or hopefully you've noticed there's a shortcut to that. 3 times 3 is 9. However, there's 9 of the smallest square. And then what's the next largest square? Well, the first time you attack this problem, you might think, oh, well, I have to count the square all the way around. Well, there is one of those, but there's a square between those two sizes, and it's the 2 by 2 square. There's one here. Notice there's a square there, 1. I'm going to try and use as many different colors as I can. Here's another square here, 2. So if I go right beside it, so shift it over 1. Hopefully you can see that as well. That's 2 squares. And then here's another one, 3. And then the last one, I'll use the orange marker, 4. Notice there's 4 of those squares that kind of all overlap each other. They're hard to count. So I have 4 of that middle-sized square. And then remember, I have 1 all the way around. And that's a grand total of 14. Now it's getting a little more challenging to count. Since I'm working systematically, you might go back and look at these numbers. Oh, I had 1, and then I had 1 and 4, and then I had 1 and 4 and 9. I wonder what's going to happen on the next one. Here's what I'm thinking. It's 1 and 4 and 9 and something else. So here's the next chessboard size. What if the chessboard were 4 by 4? Well, of the smallest squares, you can see that it's 4 times 4, there's 16. And the next biggest square will be a 3 by 3. There's 1, 2, 3, and 4. Now, as I'm drawing them, they're pretty hard to follow. You can try to follow that later yourself. But of the 3 by 3 squares, there was 4 of those. I just realized I skipped one. All right, I skipped the 2 by 2. Let's go back and do the 2 by 2. 1, 2, 3, 4, 5, 6, 7, 8. That was kind of bad drawing on that one. 8 and 9. There's 9 of those. And then lastly, you have 1 really big square that goes all the way around, right? It's always that last one large square. And in fact, I do have 149, and now I have 16. I might stop and think like, what do these numbers look like? How can I predict what's next? And if you add all of those up, you can see that you're getting to 30. Now, the idea is that you're making an easier problem, a series of easier problems out of the original problem. So this strategy, try a simpler problem, you can see me carrying it out there. And I was also working systematically by trying 1 by 1, a 2 by 2, a 3 by 3, a 4 by 4, because it now informs me before I go to 5 by 5, 6 by 6, 7 by 7. And then the ultimate question is, how many squares on an 8 by 8? I hope that's getting you started on it.